Project 3, we have our video demonstration requirements here. So the first thing we're going to do is do two different DC values from 0 to 3.3 volts. And so the first one is we're going to do is 2 volts here. And if we look at it, the DC offset about 2 volts. And then for the second one, we will change this to, let's go 0.9. And then if we look at here, then we get about 0.9, 0.88, around there. And so now for the next step of our system requirements is a 3 peak-to-peak sine wave. And we'll get our amplitude up to 3 volts. And then our offset to 1.5 volts. And our frequency down to 500 hertz. And then with these specs, then we'll look at our terminal. And as we see, we have a 1.5 volt DC offset, 1.59, 1.6. We have the peak-to-peak, about 3.2, 3.11, which if we look at the peak-to-peak being read on the oscilloscope, it's pretty accurate. True RMS at 1.12, which we see on here, 1.06. The frequency at around 500 hertz, sometimes it goes up to 512, and we have our graphs displaying true RMS and DC offset. And then up here we have it displaying sinusoidal wave. And then for the next one, we're going to do a 1 volt peak to peak. Right here. Change the trigger value, and then we're going to set a DC offset of 0.5 volts. Once we get there, let's reset the trigger value and the frequency of 1,000 hertz. So with that, we can look at over here. We have a sinusoid. Peak to peak is about 1.22, 1.12, which if we look at the peak to peak on here, pretty accurate. And then we look at the DC offset of 0.5, 1.6, a little off. Frequency is 1,000. Sometimes it goes up to 52 with some change. And then the true RMS is 440 or so millivolts, and then on here we're getting 350. So there's some error there. Once again, the bar graphs are updated and the sinusoidal wave is being displayed. Next one is going to be the 1 volt peak to peak, and then we're going to move the DC offset up to 2.5 volts. And same frequency. Get a good wave going, a little up. Find it. And we're going to look at that on our template, which we have here. And we have DC offset about 2.4 out of 2.5, frequency the same. DC offset and true RMS graphs are updating. True RMS is fluctuating between 0.55, 0.53, and we have AC RMS, a little bit of error there. Peak to peak is 1.4, 1.5. Peak to peak here, so relatively close. Still showing all of that. So our 3 sine waves are done. Now we're going to switch over to a triangle wave. And we're going to set our peak to peak equal to 3 volts. Peak to peak, DC offset of 1.5. Make sure the trigger's in the middle. And we're going to set this all the way down to 50 hertz. So we'll make it look pretty on there. And then if we look over here, we see that we're now displaying triangle wave Mainly you got peak to peak at about 3.13, 3.03. Peak to peak over here, pretty accurate. True RMS is 1.12, 0.88. 0.88 is a little bit more accurate. From there, that reading frequency is fluctuating, but it's around 50 hertz on here, and the DC offset's stuck at 1.5. We have our graphs updating, and then for our last AC signal, we're gonna have a square wave. It's gonna be 1 volt peak to peak. It's gonna have a DC offset of 1.5, and it's gonna go down to 10 hertz. And so now we have that. And then we're going to switch over here. And we have it on here. We have square wave being displayed. DC offset at about 1.5 volts. The peak to peak is a little bit off here. Frequency we can see is sitting at 10 hertz. And our true RMS is saying 0.57, 0.6, where the true RMS here is about 497. Graphs are updating, so really the most inaccurate thing here is just the peak to peak. And then for the last two, we're going to have a frequency specific. So we're going to go to a 3 peak to peak sine wave. Which we're going to be displaying on here, and it's going to have a 1.5 DC offset at the highest possible frequency. So I guess we're just going to turn this up until we start 1.5. So as we can see, our frequency is still climbing. There's some error there. We're going up, I guess it gets up to 2.5 hertz, kilohertz, 2.9 kilohertz, goes up to 4,000. And about here, we're reading 5,000, but it goes to about 4.3 kilohertz. So that's about inaccurate once we get above. Once we get above about 3.3 kilohertz, it looks like we're getting inaccurate values. And then for the last requirement, a peak to peak square wave with the lowest possible frequency. Same spec, so we'll start at 240 hertz just to show. As we can see, we're reading 240, and we will keep going down to, we're at now moving downward. We're at about 40 hertz now, about 15, 14. We're about 9 right now. 8, 7, 6, 5. We go down to here, we're at 3. We're at 2 hertz. It looks like it's breaking at about 2 hertz. But we can go up to 3. 3 hertz doesn't seem to enjoy that. Earlier I saw 3 hertz, but that's the lowest possible frequency. But it'll display, we'll find that, and then so it'll be good to go, and that'll be the end of this video for Project 3. We have our decent digital multimeter.